Okay, so question 9. Figure 11 shows 3-pin plug used to connect kettle to the mains. So we've got the outside, that's typically we see as a plug, and inside we've got the fuse, earth wire, and you might remember the other two as well. Now I've got some colours with me, because let's colour this in so we know remember. So we've got the brown, brown is the bottom right, so that's this wire here that goes here, and that is the live wire. The bottom left, bottom left is the blue wire, which is this one that snakes kind of over here. So this is the neutral wire. The brown is the live, which goes in here. So brown bottom right, blue bottom left, neutral, and then we've got the earth, which is typically green and yellow. So let's a little bit of colour to that, something like that. So that's our setup, that's the plug that we've got. A fault occurs, oh no, in the kettle, causing the live wire to touch the metal case of the kettle. So here's our kettle, here's our spout. We've got the plug here, so this plug, let's connect that to there. The live wire is now touching the metal case. Now that metal case is an important idea we're going to come to in a minute. Explain how the safety features of the plug operate when this fault occurs. So we've got the fault, the live wire in the kettle's become loose and is touching the metal casing. A little note here, folks, explain how the metal features. So we've got more than one of a plug operate when the fault occurs. And if you notice here, we're not given the brown and the blue wires, but we are told about the earth and the fuse. So there are two little clues there the examiner has kindly given you to help you plan your answer. So we'll go for the fuse wire first. So if we look at where the electricity goes to, it comes from the live, the brown terminal here, it gets screwed in here, and then it goes up and through the fuse to that pin there. And on this side, that is this pin here. Okay, so it's just going through the fuse, which is labelled. First idea is the fuse. So let's talk about the fuse in our answer. So a fuse in here is a little cartridge here, the actual fuse itself. And if you were to dismantle that, it's simply a thin wire running through it. So we've got a fault. The first thing we can say is that due to the fault, the current will rise rapidly. So we've got a big current flowing through now, which is where the danger arises from, that big current that's going to be flowing. But the fuse wire steps in here. So due to the fault, the current will rise rapidly, which will increase the temperature of the fuse wire. Okay. So you've got a big current going, a big surge here, and that's going to very quickly heat up this thin little fuse wire travelling down there. Okay, so we can put the thin fuse wire what's going to happen when it gets very hot, it's going to melt. So if this here has now, if this wire travelling through the fuse is now melted, we have now effectively introduced a switch, turned the electricity off, because the electricity can no longer flow through the fuse. There can't be a current if the fuse wire is in two parts. So if we just do a little diagram here to explain why, if that fuse wire in this cartridge here is now melted, so if you imagine it's melted at this point here, the electricity can't just jump over that gap. We've broken the circuit, so that electricity can't flow. So thin fuse wire will melt, so no current. So no current can pass. So if no current can pass, the kettle, it's a kettle, isn't it? Yep. The kettle is disconnected from the electricity supply. Now, it's a safety feature. Let's add a little bit more. The kettle is disconnected from the supply, and you cannot be shocked anymore. So the large current has melted the fuse wire. Sometimes you might see the term the fuse wire has blown. It's melted the fuse wire, so it's disconnected it from the electricity supply, and you can't get shocked anymore, making it safe. So that's talking about our first one, the fuse. You will notice it says the features of the plug. So we've talked about the fuse. What's the other feature? Well, they've kindly given us a hint here. It is the earth wire. So the earth wire. Now, what's the whole point of the earth wire? Well, the earth wire goes along and it's be attached to the metal casing. So let's put that. The earth wire is attached to the metal casing. So what this does is, because the metal casing is a conductor, it supplies a low resistant route back for the current to travel along. So instead of this casing just becoming live, and if you touched it, you'd get a shock, because the earth wire is there, it's supplying a route for that current to go through. So it's attached to the metal. So the earth wire is attached to the metal casing and supplies a low resistance route for the current to travel along. So again, because you've got that route for the current to travel along, we can say this means, let's relate it back. So asked to talk about the safety features. Let's relate it back to real life. This means you cannot be shocked if you touch the metal casing. So because it's that earth wire's there, it's got like a little get out clause, a little side way where it can the current can go down, making sure you don't get shocked. You might have come across, as a little aside, the idea of something called double insulation, which has got this symbol here. And double insulation is when the outer casing is an insulator. So that means the casing of the kettle is plastic typically, so it cannot become live. So it doesn't matter if this live wire becomes loose, because it's the outer casing is an insulator, it can't become live. So you don't need that earth wire. That's the other way this question can be phrased, in terms of why doesn't a plastic kettle need it? Well, if there's nothing you can touch that's metal, then you can't become shocked by it. So that's just a way to look out for another way this same question could be asked.